Hi folks, so in this video here what we're going to be doing is covering a question based on the topic known as the oblique plane, and essentially what we're going to be doing is a question from the Graphics in Design and Communication textbook, and it's a worksheet from that textbook, sheet 8.2, based, as I said, on the topic of the oblique plane. So as always with this problem, with any problem, you're going to read the information and then try and attempt to do what it's asking. So it says here, given is the plan and elevation of a cone which is to be cut by the oblique plane VTH. So you can see they've actually given us the elevation of the cone, they've given us the plan view of the cone, and they've actually given us the vertical and horizontal trace as well of an oblique plane. The oblique plane is essentially a plane that is cutting through our vertical plane and horizontal plane. Where that oblique plane cuts through, it leaves behind a trace called the vertical trace, and where it cuts through the horizontal plane, it leaves behind a horizontal trace. Okay? And then it's saying complete the plan and elevation of the cut solid. And you can also see here, they're after giving us an x1, y1, okay, and it is that x1, y1 is set up perpendicular to our horizontal trace. So essentially, if I put another pen there, they are perpendicular to each other, they're 90 degrees to each other inside there. Okay, so the horizontal trace is this way, the x1, y1, which is our auxiliary view, is perpendicular to it. Okay, so the only way we can actually complete this question is when we see the oblique plane cutting through the object. And the only way we can do that is when we see the oblique plane as what is known as an edge view. So we actually have to get an edge view of our oblique plane. So we're going to look along the horizontal trace to see it as a point view here, and then we'll take a vertical height as well. But before I do that, before I even look at the oblique plane as an edge view, I'm going to get my cone up here in an auxiliary view. So to do that, just looking here, I'm just going to set it up to see does it work out that it's at 30 degrees. It's actually perfect there. So you can see there my horizontal trace is at an angle of 30 degrees. So from the apex of the cone in the plan view, which is the center point, I'm going to project this up. It's going up at 30 degrees. It just so happens that our horizontal trace is that way. I'm also going to project up the outside of the cone as I'm looking from this direction here. So the furthest left of the cone, as I look in this direction, the furthest left of the cone is here, and the furthest right of the cone is here. So I have to bring up those as well. They will be on the ground. When we're doing an auxiliary elevation, we project from the plan, we take our heights from the elevation, but obviously we're just getting another view of the cone as when it's on the ground. Okay, now that I've got that, I need the height of the apex. So I'm going to take this height. I need the height of the cone, which is the height from the XY line up to here. Project from the plan, take your heights from the elevation. And then where the height of the cone is here, I'm going to mark it up. Okay, that there is the apex of my cone. I'm now going to draw in the cone seen from our auxiliary view. Okay, so there is our auxiliary view on our x1, y1. Okay, and we've got the cone when we took the height from here. Now the next thing I will do, anytime you have a cone, I'm just going to do a little sketch here. If I just take a cone here for a second, and draw in as best I can. If we imagine, okay, so there's our cone. Now in any cone, what you have to create a cone is when you revolve a triangle about an axis. Okay, so from the center line of the cone there, I'm going to come down here ever so lightly. If you imagine there is the center point of our circle on the ground, that will come out to here, like that. And this point here will connect back up to the apex. You can see a little triangle in there now. Okay, that triangle essentially spins around this line here, which is called the axis, AXIS. But this line on the outside, which is the long edge of our triangle, the hypotenuse, that will stay going around the outside and goes in a circular pattern, and it helps us to create the cone. What that line is known as is a generator. Okay, that is a generator, and essentially that generator goes around and it creates the shape of the cone. What we need to do is we need to create multiple generators on our plan view and the elevation, and then project them up. So the easiest way to do that, anytime you're working with a cone, okay, is using 30, 60 degrees. So I've already gone 30 degrees through it. I'm now going to go 30 degrees in the opposite direction. I'm now going to go 60 degrees. And then finally 60 degrees the opposite direction. Okay. I like to number my generators. So these are generators. I'm going to call the apex O. So technically that would be O1 because we're on the X1, Y1. And then all of the rest of them, I'm just going to number them like a clock. If that's 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Okay. Now I need to find all of those in the elevation. So number 9 would just come up to there. Perfect. 10 and 8 are in line with each other. 7 and 11. 12 is there. I've got 5 and 1. 2 and 4. And finally number 3. Okay. Just bring it up there. Perfect. Okay. Now that I've done that, I want to number them in elevation. So number 9 is here. Then I've got 8 and 10. I've got 7 and 11. The reason I put the 11 on the other side is because it's behind. Okay, it's at the back. I've got the number 12, which is already there, and I'm just going to put number 6 here as well, because the 12 is already here, obviously, how I numbered it. I've got the number 1, 2, 3, 4, and 5. Now, every one of those generators, I also want to connect up to my to the apex, which is point O. The middle one is already up there. And finally this one. Okay, so there's all my generators. Okay, there's O at the top. Now that I've them labelled here, I also have to label them out here on my auxiliary. So, number 5 is brought out. Number 6 and 4. Extend those out. Number 7 and 3. That one's brought out. Now I'm not bringing the line the whole way across just for neatness, because you can see that 1 is in line with 9 and finally the 2 is in line with the 10. Okay, and once again numbering those. Now remember, we're looking in from this direction. Okay, that there slightly, sorry, and then got 0 at the top. So I've got 2, 3, just want to find my pattern, 4, 5, 6, 7, 8, 9, 10. We've got the 11 on the outside, then I've got the 12, 1 and 2. Okay, so every one of those will also connect up. Okay. All right, so there we have our generators. Now what those lines are essentially, as I told you, one of these lines, but as you can see then, it's possible to have multiple of them as they go down along the object. They're all called generators. Now what we need to do in the auxiliary view, we're going to see the horizontal trace as a point view. Looking out along here, this point right here is going to be a point view of HT, of horizontal trace. That point right there is a horizontal trace, because anytime I look along a true length, okay, the horizontal trace is a true length. Anytime I look along a true length, principle in graphics, you will then see it as a point view in the auxiliary. Okay, next thing I want to do is I need to take a point from the vertical trace. So I'm actually going to take this one here. The reason I'm taking this one is because the line is already projected up. That one right there, I'm going to put it in dark. I'm going to take that vertical height from there up to there on my compass. So this is the height of a point that is on the vertical trace, that height right there. I projected it out along here. I'm now going to mark it from the x1, y1 up. You can see that point there is a point then on my vertical trace, and this is the point view of the horizontal trace. So technically then, that there is an edge view of my oblique plane. So edge view oblique plane. Now what do I need to do then? What's helpful about that is when I've got the oblique plane as an edge view, when I'm seeing that plane as an edge view, I can see where that plane is cutting through all of my generators. So this generator number 11, it's being cut right there. This generator 12 and 10 is being cut right here. This generator 1 and 9 is cut here. This generator here, which is the 2 and 8, is obviously cut right there at the height I did. The 3 and the 7, the 6 and the 4 and the 6, and finally the number, I think this one is the number 5. Yep. Now, where every one of those cut points are, now that I've found them in my auxiliary view, I need to project them back to my plan. So if I want to find where the number 11 one is, where it cuts there, I need to project it all the way back, and I can mark it here. Okay, so if you want, you can do the line the whole way, or alternatively, you can just make a little mark. So for the first one, I did the line the whole way, and that's after identifying to me where it cuts the 0 to 11 generator. And it cuts it right there. Okay, at this point now, I'm just going to keep it neat and tidy. This one is cutting the 12 and the 10. Go by your numbers, so the 12 and the 10. So I'm just going to mark it there and there. I'm happy with that. The next one is cutting the 1 and the 9. 1 and 9. The next one, I'm going to skip that one. The reason that one is tricky is because you can see that where it cuts it is actually on a parallel line, so I can't find exactly there yet. So I'll tell you what we're going to do there in a second. The next one is the 3 and the 7. So I'm going to mark it. There's the 3. There's the 7. The next one is the 4 and the 6. So looking at my number, there's the 4. There's the 6. And finally, the number 5 down there. So you can see all my marks there. I like to go over them just a little more clearly. Just finding them all there. And you can see here the shape that we're roughly making, okay? So obviously we're going to have a point maybe around here and another one around here as the curve goes. But the truth is you cannot simply just guess where those points are. Even though we'd be able to have a fairly accurate guess, it's probably somewhere like there and maybe somewhere like there as well. You cannot guess those. So for the one here, where our oblique plane cuts through our generator, but the problem is our generator is perpendicular to the x1, y1. Okay, so the only way we can actually figure that out is when we actually create what's known as a horizontal cutting plane. So parallel, I'll actually switch out my set squares there. Parallel to the x1, y1, I'm going to set up a horizontal cutting plane. Okay, now when I set up that horizontal cutting plane, I'll write that in. Horizontal cutting plane. Technically, let's imagine if you're looking at this auxiliary view and we're looking obviously at the top of it has been cut off. What shape would we see? We would see a circle here if we cut off the top of it, where that horizontal cutting plane is. Okay, so what's helpful to me then is on the outside generator, in this case the number 5 and in this case the number 11, this one here, the outside generator, the one that actually helps us see the shape of the cone, the triangle part, right here at this point, okay, which is actually on the generator 0 to 5 once again, is where it's cutting through it, okay? That's called our extreme generator. Where it's cutting our extreme generator in this case, what I'm going to do is I'm going to project back number 5 to where it's cutting here. And remember now, it's cutting on the number 5. So I'm going to project that all the way back there, nice and light. And you can see there, it's cutting right here. Now that's inside our object. However, that's not the point I want. The point I want is here. So what we're going to do then is, remember what I said, when we look down on top of it and we can see this horizontal cutting plane cut across, what shape would you see when you look across it? You would actually see a circle. So we actually are going to rotate that circle now from the center to the 5 mark when it's on the extreme generator, and I'm going to rotate it until it's on the 2 and the 8. So I'm going to take this and I'm now going to rotate like that and like that. And there we go. I'm not going to do the full circle, but it cuts through right there and right there. And there I have now found my other points. So, just to complete this, what we want to do now, we've now found all the points. What we're going to do in the plan view is we're going to simply sketch in the curve. So as best I can, between all the points, using a biro now, so I'll do the best I can. And draw all the points like this. Trying to follow what I think the curvature would look like. And down here, back up. So that is identifying to us then where the oblique plane is after cutting through our cone at an angle. So anytime you've got a cut surface, nearly all the time you're going to have to set up an auxiliary view, unless it is an upright solid. Okay, when it's got a cone or a pyramid, you're always going to have to set up this auxiliary view. Auxiliary view will be projected perpendicular to the horizontal trace. Okay, there is our cut surface. Now that we've identified that in the plan, we also must identify that in the elevation. So, where all our cut points were on our generators, we have to find those. So I'm going to start with the number 1. So there is the number 1. I'm going to find it there. I'm going to project up. You can see it's cutting right there. That's on the number 1. So that's my first one. The number 2 is the next one. And once again, you don't have to always project up. There's the number 2. Okay, I'm just going to project up for these ones. There is the number 3. It's on the extreme. Then I'm on to the number 4. Then I'm on to the number 5. Now, once again, we have an issue here with the number 6, okay, because you can see here, if I just bring that up, I can't exactly identify where that is. So I'm going to leave the number 6 and the number 12 one until the end. I'm going to skip on to the number 7. Number 7 seems to be about here. Then I'm on to the number 8. There's the number 8. Number 9 is right here. Then I'm on to the number 10. It's right there. And then finally number 11. You can see it's right there. Okay. Now the other ones I have to find are obviously on the number 12 and 6. Once again, I could probably have a fairly good guess. The number 12 is in there somewhere, and the number 6, it might be over around here. So at this point, there's actually 2 ways you could do it. You could use the principle of a horizontal cutting plane. In the plan view, we would actually just simply take the 12 here, rotate it onto the extreme generator, which is the 0.9 or 0.5, project that up and across. But the easiest way to actually, I think, to do it is just do normal point location. Okay, so for the number 12 one, if I just take that one as an example, I'm going to set up my 45-degree set square parallel to my horizontal trace. I'm going to project parallel from the horizontal trace, from the number 12 to the horizontal trace. Okay, where it hits the XY line, I'm going to now project it upwards to hit the vertical trace, and where it goes across will show me where number 12 is. That's where I think the easiest method is. So parallel to the horizontal trace, project up vertical to hit the vertical trace, and then across we'll find it. And the exact same then for the number 6. So once again, parallel to HT, number 6. From there, we're going to project it upwards, hit the vertical trace, and once again across, and we'll identify our final point. Okay, now that I've found all of those, I'm simply going to sketch those in. So as best I can, I'll usually go to where they're a bit closer to each other first of all. Try and find the shape of it. Depends on your accuracy. And there is on the number 2. This one here is on the number 1. Probably actually a little bit out on that one, so apologies there. Actually just looking there at how I drew it, yeah. Definitely out. Sorry for that. So you can see the difference it makes by 0.5 mil. It's actually out there. I was thinking that was far too far out. So there's number 1. That's looking better. There's the 2. Down to the 3. 3 into the 4. 4 to the 5. As best I can. The 5 is going to go up to the 6. To the 7. And to the 8. And you can see the shape that it's making there. And now what we're going to do is heavy that in. So you can see it looks quite complex, but when you break it down, the first thing that we did with the auxiliary was simple orthographic, an auxiliary view. Then what we did was we set up our generators, and once we got our cutting trace, it was just a case of following all our points back. And there we go. There is the cut surface. Now what I would usually do here, I'm actually just going to use go with a red. We'll go with a blue. So where the oblique plane, which was this guy here, cut through the face of the cone, just going to put it in a highlighter of the blue. That's the cut surface right there. Now, what does that cut surface look like in the plan? I would simply come along as best I can, and I would shade that in. Okay? Always identifying with color, because that's showing the cut surface. Just get that done. Probably could have gone a little bit quicker with coloring pencils. So that's my plan view of the cut surface as I cut off the top of the cone. And then over here then, above here I should say, is the elevation view. So just finishing that off. And just identifying what that looks like. Now that I've done the outside a little bit quicker. There we go. Okay, there you have it, guys. That was the question on number sheet 8.2 based on the topic of the oblique plane, where we showed how to find the cut surface in the elevation plan of a cone that has been cut by an oblique plane. Okay, I hope you found that helpful. That is the question complete. Okay.